focuses on designing a spherical pressure vessel with an appropriate thickness such that the maximum normal tolerable stress would be equal to the yield strength of the material being used. So what we see here is a spherical pressure vessel, generically described, with having some axial stresses on the surface or in the thin wall of the material of that vessel with sigma, an internal pressure P, and the relationship that we've previously derived relating the pressure, the radius, the thickness of this spherical pressure vessel to the sigma, the stress in the walls. So we are given the maximum tolerable normal stress. That's going to be the SY, or the yield strength of the material. And we also know that we have a relationship for the normal stresses in the thin-walled spherical pressure vessel, namely sigma equals PR over 2T. So we're going to equate this SY, this tolerable yield strength, to the sigma. And the volume is specified in the problem, so we can calculate the radius r. The volume for a sphere is just 4/3 pi r cubed, and we're going to ignore the fact that, oh, is this the inner radius or the outer radius, because we're assuming that this is a thin-walled vessel, and so the r outer and the r inner are going to be pretty close to each other. So for our intents and purposes, we can just call it r, just like we're calling it r over here. And so going ahead and solving for r, we have the following. The cube root of this quantity 3v over 4 pi, where v is the volume, will give us the radius for our thin-walled spherical pressure vessel. We can now go about trying to figure out the thickness, T, for this pressure vessel. Where do we see the thickness? Well, the thickness was in the equation for the stress. And so we take this equation over here, we rearrange things, and we get that the thickness is just going to be equal to PR over 2 times the yield strength. We then substitute in this R, and we now have our formula that we can use to figure out what the thickness of the spherical thin-walled pressure vessel might need to be, given the volume that's desired for the spherical pressure vessel, given the yield strength of the material that might be used, and given the internal pressure. I won't do it here, but you could go ahead and use Colab or Google to be able to perform these next calculations. Thank you. I hope this video is useful.